Alright, so we need to find g prime using the limit definition. And recall the limit as h goes to 0 of g of x plus h minus g of x all over h. Alright, so like always, I have g of x, I have h, I just need to find g of x plus h. So everywhere we see an x, we're going to replace it with x plus h. And then we'll plug it into the limit definition. Now I need to evaluate the limit. So I'll have to do a little algebra. Remember, if I try to do direct substitution, I will plug in 0 for every h, and I'll end up dividing by 0. I'll actually end up with 0 over 0, which we can't have, so we gotta do a little algebra. So I'm gonna multiply the top and the bottom by what I consider the fraternal twin of my numerator. They are fraternal because they look almost alike, except for instead of a minus sign in the middle, it is a plus sign. I'll make sure not to multiply out the denominator. So I'll go ahead and write that. But I am going to FOIL out the numerator. So we end up with x plus h minus 3. That falls out of the square root. This multiplied by that would be the square root of x plus h minus 3 times the square root of x minus 3. To save a little time, I need you to understand that when you multiply this by this one, you'll end up with the same thing except for it's with a minus sign, so they should cancel each other out. So I tell you what, let me go ahead and write it out. So square root x plus h, minus 3 times square root x minus 3. Now of course you can put them underneath the same square root together if you wanted to. Just use parentheses. But like I said, they are the same terms, so they will actually cancel each other out. So let's finish it off by putting the minus. And then for this piece, I am going to put in parentheses. Otherwise, I will mess up a sign. Okay, so negative square root of x minus 3 times the square root of x minus 3. Well, the square root cancels out. The x minus 3 falls, but it's a minus sign on the outside, so we absolutely need parentheses, or you have to negate each term. But for now, let's just show all the work. All right, so now let's clean up what we can. These terms cancel each other. We're going to distribute the negative 1 on the inside. Rewrite my limit definition. Keep my denominator intact. No reason to distribute. All right, let's see what we have left on the top. So over here, this is going to become minus x plus 3. X will cancel with minus x. Minus 3 will cancel with positive 3. So I see I'm left with h on the top, and that is it. So I'll put the h. Now notice the reason I did not distribute in the denominator is because now I can cancel the h in the numerator and the h in the denominator, and I'll end up with the limit as h goes towards 0, 1 over square root of x plus h minus 3 plus square root of x minus 3. And then from here, we'll apply direct substitution. So we'll go ahead and plug in for 0 for h, and we'll end up with 1 over square root x minus 3 plus square root x minus 3. Of course, we can simplify this further by putting these together. And then we'll end up with a final answer of 1 over 2 times square root x minus 3. So again, g of x was equal to the square root of x minus 3. G prime of x is equal to 1 over 2 times the square root of x minus 3. We found the derivative of g of x using the limit definition. Eventually we'll get into shortcut methods, and the shortcut method also will end up with the derivative of g of x being 1 over 2 times square root of x minus 3. Alright, so hopefully this was a good example. Have a good day.